Okay, I think now I'm audible. So, hello everyone. Hello everyone. Welcome to Gate Wallah English YouTube channel. So, I hope यहाँ तक everyone is fully clear. So, till last class we have discussed about flow mass curve, measurement of stage and measurement of velocity. Okay, today we are going to discuss the methods with the help of which we are going to do measurement of discharge. Okay, so perfect. Now everything is clear. This will be very great class because in this you will see some different unique methods of how to measure discharge. Okay, which generally you will not find anywhere on YouTube. Okay, so till the last class we have discussed your flow mass curve. Okay, I told you what flow mass curve exactly is. So flow mass curve is nothing but simply your integration of hydrograph. Okay, this we have already discussed. And if someone asks you like what flow mass curve gives, so you will tell that flow mass curve gives me, sir, reservoir capacity. Okay, because behind reservoir, sir, water will go on accumulating and we will get the, and this cumulative discharge is nothing but your total volume. Okay, so how much volume of water has been stored behind reservoir we can find with the help of flow mass curve. Then we discuss stage velocity discharge thing. In stage, sir, you told me that we have some manual methods in which we have staff gauges, we have wire gauges. Okay, so we have discussed these manual methods. After this we have discussed some automatic methods. Sir, in this automatic methods, sir, automatically the stage graph with respect to time is plotted. Okay, variation of stage or simply the depth with respect to time is plotted. Okay, we have bubble gauge and we have float gauge. Then, sir, you told me about current meter. Okay, current meter is very important. Okay, this can be asked in your examination. Basically, at any depth, if you want to measure velocity, you will use current meter. Okay, this we have already discussed. Then we have discussed that it is of two types. What is sounding weight? It stabilizes the current meter. Then this is the equation which is utilized in your current meter. We have also solved one numerical which has been asked in gate examination regarding your current meter. Okay, good evening, dear. Good evening. Okay, then I hope this numerical was very clear to you. Now today we will be discussing your measurement of discharge. Okay, this in the last class also we have discussed about how to find average velocity. Okay, we have one method for average velocity for shallow streams which are which are having depth less than 3 meters. So their average velocity was v.6. In 2-point method, which are certainly, you can say, which are moderately deeper streams, in that one I will use 2-point method. Okay, we have surface velocity multiplied by reduction factor, then also we can get average velocity. So some field methods were there. This distribution was logarithmic in nature. Okay, sir, understood clearly. And sir, you told us about some field use formulas. Okay, some application we also discussed. Now today we are going to discuss the measurement of discharge. Okay, so till now I hope everything is clear. We are going to start with this topic. Okay. Okay, sir. So the very first method which we are going to discuss today is your area velocity method. Okay, see, area velocity method becomes important because it has been asked in GATE 2023 itself. Okay, that's why I'm going to discuss it beautifully. So area velocity method is important because it has been asked in GATE examination in the recent year itself. Okay, so let us try to understand how with the help of area velocity method you are going to find discharge in any stream, in any river. Okay, so tell me the method. After area velocity I will discuss dilution technique, electromagnetic, ultrasonic. Okay, these 6 we have to discuss. So we'll move ahead one by one. We'll discuss all the methods. Okay, so I hope all these things are clear to you now. Now the first method is your area velocity method. Okay, as the heading is there. See what happens in area velocity method. What I do, I divide the entire section. Listen very carefully. Okay, let us say this is my stream. Okay, let us say this is my stream, sir. Okay, let us say this is my stream. Okay, sir, no problem. And this is the level of water. This is the level of water. Okay, sir, that is also clear. Now I will move across this river or stream on a boat which is moving from point A to point B. Let us say this is point A and this is point B. Okay, sir. Okay, sir, I will be moving from point A to B. Okay, after every certain interval, let us say after 3 meters gap, after 1.5 meter gap. Okay, we will stop our boat. Okay, this is your boat. Let me draw a boat here because this method is also known as moving boat method. Okay, so this is your boat. This is your boat, and obviously one observer will be there in this boat. Yes or no? And see, the duty of this observer is to measure 2 things. Okay, one is depth and next one is velocity. Listen very carefully. Okay, sir, what he will do, see, after certain intervals he will measure depth here by 1. Okay, yes, like this. Firstly he will measure depth here. Let me draw straight lines here with the help of which it is very clear. So yes, he will measure depth after certain interval. Then again he will measure depth. Okay. So depth will be measured after certain intervals of time. Okay, depth will be measured after certain intervals. This is very simple thing. I hope this is clear. Okay, sir. So at we can say 1, 2, 3, 4, 5. At 5 points, sir, depth is being measured. Okay, sir. Let us name them as y1. This is y2. Okay, this is y3. This is y4, and let us say this is y5. Understood, sir. Beautifully understood. So my boat is moving from point A to B, and after certain, let us say 3 meters gap, depth is measured. This is the very first step. Okay, is this thing clear? Yes, sir, it is very clear. Now the second step is I will also measure velocity. Okay, sir, at what depth I will measure velocity? Sir, it is up to me. Sir, it is up to me because, sir, you told me in the last class that velocity can be measured at 0.6 times the total depth. Okay, simply, or at 0.2 times or 0.8 times. Then I will take average velocity. See, if we want to find average velocity, what I will do, I will go up to the depth of 0.6 times the total depth, and here I will measure velocity. I will lower the current meter. I will submerge the current meter up to which depth? 0.6 times the depth, or I will find velocity at 0.2 times the depth and 0.8 times the depth, and I will take average. So both options we have, but simply you need to understand at all the points, sir, velocity will be taken. Okay, understood. Sir, what else? Sir, we will take velocity also. Let me call this velocity v1 average, v2 average. We will find v1 average and v2 average. Okay, that is up to us. Obviously, that is up to us. v3 average. Here I will find at this section. Okay, I will find v4 average. Here I will find v5 average. Understood, sir, clearly. Okay, we will lower the current meter up to 0.6 times the depth, or 0.2 times or 0.8 times. We can take anything. Okay, it depends on us. So this is a moving boat method in which at certain intervals I will take depth and velocity. Okay, now what else? See, after this thing, listen very carefully. After this, I will divide my entire river section or stream section. I will divide my entire section. So listen very carefully. After this process, after this measurement of depth and velocity thing, I will divide my entire section into n segments. Entire section is divided into n segments. Okay, listen very carefully here. Entire section is divided into n segments. Okay, sir. How these segments are divided? Kindly tell me, sir. So the very first segment is, see, we have two corners. One is, this is your first corner, and that is your last corner. First segment and last segment. So first segment is taken as, you can say, full, this portion is taken completely, and this portion is taken almost half up to here. So this one is your first segment. Listen very carefully, sir. This is my first segment up to, from this point to this point. This is my first segment. Understood, sir? This is the first segment. Okay, sir, this is my first segment. This is the first segment, and this is your last segment. Okay, this is your last segment. This is last segment. Okay, so this is my last segment. Okay, sir, this is also clear now. This is first segment, this is last segment. And what about intermediate sections, intermediate segments? So intermediate is, take half of this and take half of this. Okay, take half of this and half of this. This is your intermediate section. Okay, this is your intermediate section. Sir, this is my intermediate section. This is my intermediate section. Listen very carefully, otherwise you will get confused. Okay, these are what? These are my intermediate sections. Okay, so overall, sir, I can see here. Sir, this is my, wait a second. So this is my second segment, sir. This is my third segment according to your explanation, sir. And this is my fourth segment. So overall, sir, we have, sir, overall you are saying, simply, sir, I have two corner segments. Okay, let me write it with the pink ink only, because with pink, or I have shown corner segments, last segment. So this is my, this ink is simply showing this first, and see, generally we denote it by I. Okay, and I varies from 1 to n. So we have basically divided it into 5 segments. Okay, you can see this from here. So first and last are your corner segments. And these are remaining with which we have marked with brown ink, are your intermediate segments. Okay, so 2, 3 and 4 are your intermediate segments. Is this thing clear? Sir, is this is clear? Now sir, why we are doing this? The question arises, sir, why we are doing this? Okay, listen very carefully, you will get the entire concept. This question has been asked in GATE examination. Okay, so listen very carefully. So this is my intermediate segment, sir. These are my intermediate segments. Okay, now what I have to do, I have to find discharge in each and every segment. I have to find discharge in each and every segment, and at last I will sum up all the discharges to get the combined discharge through this entire section. Okay, sir, you are saying we have to find you are saying, sir, we have to find discharge. Okay, sir, we calculate discharge. Sir, we calculate discharge using the formula. We calculate discharge using the formula Q equals summation I equals 1 to n. Okay, and this is your delta Qi. See, what is the meaning of delta Qi? Delta Qi, I will vary from 1 to n. Sir, here we have 5 segments. Yes, sir, you are beautifully explaining the example. Sir, here we have 5 segments. So I will find discharge in the first segment. Then I will find discharge in the second segment. Then I will find discharge in the third segment, fourth segment and fifth segment. And then I will sum it up. Okay. Yes, sir, understood. So what is this delta Q, sir? This delta Q is what, sir? This delta Q is simply segmental discharge. This delta Q is nothing but simply my segmental discharge. Understood. Sir, now the question arises, yes, sir, this is true. Simply find the discharge in each segment and add it up. Now, sir, how I will find this segmental discharge? So the formula for this segmental discharge is, this is your, okay, now the segmental discharge we can find. See, for segmental discharge, we need to find average width. I will write second step here. See, this formula will be written as, n equals to 1 into, n equals to 1 to, sorry, I will be equal to 1 here, from I equal to 1 to n. Now, how I find discharge? See, discharge is area into velocity. You all know this. And area is what? Area is width into depth. If we have a rectangle, suppose we have a rectangle and the width is w. Okay, sorry, width is w and depth is y. So area will be w into y. So I will write here, sir, that area is what? We all know discharge is area into velocity. So area will be w into y. W of ith section, depth of ith section segment. Okay, let us say it is first segment or it is second, and average velocity of that section. Yes or no? So I will do what? I will find segmental discharge by multiplying average width. Okay, this is what? This is your average width by the depth by your average velocity. Okay, now, sir, tell me how I will find average width, how I will find average depth, how I will find average velocity. So we have to find these 3 terms. Okay, we have to understand these 3 terms, with the help of which we will be able to find the discharge easily. Now, sir, listen very carefully here. See, for first and last segment, how you will measure the average width? Okay, the question rises, sir, how I will measure the average width? Okay, so I will write here the very first point. The very first point is, for first and last segment, I will write here. I will write on the next slide, okay, so that it is more clear. For first and last segment, sir, average width, effective width, okay, we call it as last means corner segment. You all know this. So for that, first and last, the effective width is, let us say for first one. Okay, let us say for first one. So for first one, sir, average width is, I will write W1 average because it is the first one. How it is computed? Average width is computed by simply by taking this formula, W1 plus W by 2 upon whole square upon 2W1. This is for first one, and for last one we have W2 average, sorry, not W2, Wn, because it is the last one. It is the nth segment, so I will write Wn average, which is given as Wn plus Wn minus 1 by 2 whole square divided by 2Wn. So these are the formulas with the help of which you will calculate average width for first and last segment. And if we have any intermediate segments, let us say we have intermediate segments, middle segments. If we have, let us say we have middle segments, Then for those middle segments, sir, I will calculate width. Okay, the width will be given by, let us say, average. Okay, W average. Simply how? We will multiply width, we will take average of both the widths. Okay, simply we will take average of both the widths. Sir, I have not understood this. Kindly explain this with the help of an example. Okay, so we have to understand an example in order to understand this. Okay, so after this width thing, okay, after you have find out the width, multiplied by depth, corresponding depth, and multiplied by average velocity to get the segmental discharge. And at last, what I will do, at last, see, what is the first step? This is your first step basically. This is your first step. Basically, this is your first step. You have to do this, otherwise you will not be able to find your discharge. Okay, so at last, the total Q will be, at last, summation Q will be what? At last, summation Q will be what, sir? It will be discharge for first segment. It will be discharge for all the middle segments. It will be discharge for all the middle segments. And at last, it will be discharge for the last one. Okay, sir, for this first segment, I will use this average width. For last segment, sir, I will use this average width. And for middle segments, I will use this formula. Okay, sir, now tell me how I will use this. Okay, now tell me, sir, how I will use this formula. Okay, so in order to understand this beautifully, let us take an example. Okay, let us take an example with the help of which we will be able to understand clearly. So, sir, tell me. So let us take this example only. Let us take this example only. So in your river, let us assume we are moving from this end to this end. Okay, and after every 3 meters, let us say this gap is 3 meter. Okay, so tell me how many breaks we have taken. This is your W1. This is your first width, W1. Again 3 meter. Again 3 meter. This is W2, same. Again 3 meter. Okay, after every 3 meters, sir, we are taking a halt and we are measuring depth and average velocity. Okay, so this is W3. This is W4. This is W5. And at last, we have W6. Okay, after every 3 meters, sir, we are just simply stopping. Okay, so how I will write this question? I will write that whenever when I'm moving from point end A to B, okay, I am simply stopping. Let us say this is 0. After 3 meter, after 6 meters, after 9 meters, after 12 meters, 15 meters, like this. Okay, see, if we will talk about this, so 0, 3, 6, 9, 12, 8, 15, 18. 18 is the last. 18 is the last step. 15, 18. So this is your last destination. See, now what else? Sir, after this, sir, at every place, what we did? Sir, firstly, we measured the depth. Sir, what we measured? We measured the depth, which is given in the question, which is mentioned here. Okay, sir, we have measured the depth. Okay, sir, tell me the depth which you have measured. See, listen very carefully. At 0, you have no depth. At last 18 meter, you have no depth. Okay, these are all 3 meters gap. Okay, so depth will be here, like this, y5 till depth will be for the intermediate ones. So the depth which we have measured is, the depth which is given here is, let us increase these depths. Okay, let us say the depth here is 0.6 meter. Again, now depth will increase. So let us say it is 2.5 meters, not that much. Let us say it is 1.5. Now let us say it is 1.9. Okay, now let us say again it is started to decrease. Let us say it is 1.6 meters. Then let us say it is 0.9, and again it is 0. At starting and ending, we have 0 depth. Sir, this is very, very clear now. Okay, after this depth, you have measured velocity at 0.6 times the total depth. Okay, after this, let us say you have measured velocity at 0.6 times the total depth. Okay, sir, what velocities we have? Obviously, at first and last segment, in meter per second, obviously at first and last segment where there is no depth, no velocity will be there. Okay, we have measured velocities. We have lowered the current meter up to 0.6 times the total depth, and we have measured the velocity there. Okay, let us say velocity is 1.4 meter second. Let us say here it is 2.5 meter per second. See, more you can say more closer you are to the middle reach, when you are in the middle, you will see higher velocity will be there. Okay, you will witness higher velocity there. This is a basic fact. You need to understand this. Okay, sir. So these are the velocities at 0.6 times the total depth which we have measured. So we can directly consider this as average velocity. Okay. After this, what we have to do? See, in this question, only this much is mentioned. Okay, only this much is mentioned. Now we have to find some other things. Okay, these things are mentioned to me here. Okay, now what else I will do? See, sir, I need to find only three things. Okay. Sir, I need width, I need depth, I need velocity. Okay, sir, after moving your boat from point A to B, sir, depth and velocity are under my control. Now, what I want only is, I want only average width. Okay. So after this, I will make a formula. I will make a column for finding effective or average width. For finding effective or average width denoted by W bar. Okay. Now, sir, if I want to find, listen very carefully. Listen very carefully. If I want to find the first average width, the formula is W1 plus W2 by 2 whole square. See, W1 is, see, you need to understand. So you need to understand, this is W1, this is W2. Take half of W2. See, W1 you have to take completely, but W2 you will take half. So W1 plus W2 by 2. This is W2, this is half. So W1 plus W2 by 2 whole square. Okay, sir, if I will find, see, you need to understand, this is first third meter, this is W1 and this is W2. Understood, sir? Now what I will do, in order to find first average width for the first segment, I will do what? I will do W1 by W2 by 2. So W1 is 3, W2 is 3 again, then 3 by 2. Okay, we have to take half of it, then square it, divide by 2 into W1. Okay, so when you will see, you need to understand this very carefully. Why we are taking W1 completely and why we are taking W2 by 2? Because in this diagram you can see, W1 is complete and this is half. Yes or no? Yes or no? See, don't worry, Sushil, I will give you the answer why we are using WY here. Listen very carefully first. Okay, so tell me what is the value for W1 here? Tell me what average depth we are getting here. Sir, if we will solve this will be 3. Okay, this is 1.5, 4.5 whole square. This will be 4.5 whole square, which is 20.25 divided by 6. Okay, that if divided by calculator, you will get it somewhere around 3.375. You will get it as 3.375. Okay, so you will write 3.375 in the middle of this. So in the middle of this, we have 3.375 meter. Okay. Yes, sir. Understood clearly how we have reached to this, or let us write it here only. Okay, sir. See, W1 average and W last average. Okay, for first and last, average will be calculated like this only. Okay, for first and last, both of them, for both of them, sir, we will have 3 plus 3 by 2 whole square divided by 2 into 3. So this will be equal to 3.375. Understood? So sir, you are simply saying for first and last. So this is for the first one and this is for the last one. For last one also we have 3.375. Okay, don't worry. I will explain everything. You will understand each and every concept, Sushil. Just don't worry. Listen here carefully. Okay. Now what about the middle segments? Sir, now what about the middle segments? Sir, you have told me, see, again Wn is 3 and this is 3 by 2. This is 3 by 2. This is 2 into 3. Already discussed. Okay, so for first and last, sir, for first and, see, for first one, 3 plus 3 by 2 whole square divided by 2 into 3. For last one, sir, 3 plus 3 by 2 whole square divided by 2 into 3. This one. Okay. Same. Now for intermediate ones, what we have to do? Sir, I have to take half of W2, take half of W2 and take half of W3. Half of this is 3 by 2, half of this is 3 by 2. Okay, I hope why we are taking half, this is clear. Why we are taking half, this is very, very clear to you. Because you can say, you can see that this is a kind of rectangle. This is a kind of rectangle which is being formed after, you can say half segment we have taken from here and half segment we have taken from here. Okay. Understood, sir. So what we are taking? 3 by 2, 3 by 2, 3 by 2, 3 by 2. So intermediate widths. So for intermediate sections, let us write here. For intermediate sections, sir, what I have to do? I have to do, sir, simply take average of 3 plus 3 by 2. Okay. First width, second width divided by 2, you will get it as 3 meter. Okay. So for all of them, So for all of them, you need to understand. Okay, sir. So for second segment, sir, this is 3, this is 3, 3 by 2, 3 by 2. So 3 by 2, 3 by 2 is 3. So we will write 3 meter here. Okay, for next segment, for the third segment, see, this is for the first segment, this is for the second segment. For the third segment, 3 plus 3 by 2, we will again we will have it as 3 by 2 or 3 meters. Again, we will have it as 3 meters. So these are your 5 segments. So these are 5 segments. Understood, sir. Now the first segment is having average width of how much? Now, sir, listen very carefully. We are considering all these segments. Listen very carefully, sir. We are considering these 5. 1, 2, 3, 4, 5. We are considering all these segments as rectangular segments. Okay. We are considering all these segments as rectangular segments. We are considering all these segments as rectangular segments whose area will be given by average width into your depth. Average width into your depth. This is your area of rectangle, approximate. Okay, you all know that this is obviously rough in shape. Okay, some line will be here and there, but no worry, we are just approximating our answer. Sir, what we are assuming? We are assuming that all these are rectangles. We are assuming all these are rectangles with average width. Okay, see, actual width is W1 plus W by 2. But this is not a rectangle. So in order to convert this to rectangle, we have used these formulas. Sir, why we are using these formulas? Sir, we are using these formulas in order to convert them to rectangle. Okay, sir, we are using these formulas in order to convert them to rectangle. I hope this is clear to me. Okay, so average width is multiplied by the depth. So listen very carefully. See, this first segment is converted into a rectangle. This first segment is converted into a rectangle of depth y1. Depth will be y1 only, and width will be average width. Width will be effective width. Okay, similarly, second segment will be converted into rectangle of depth y2 and width average width. Okay. Okay, Sushil, is this thing clear? We are just assuming. We are just assuming it. You are asking, na? So we have converted all these segments into rectangular segments by using average width formula. These are average widths. Understood, sir? Now, if I want to find discharge in all of them, if I want to find discharge in each segment, then what I have to do? I have to multiply average width by the corresponding depth of each rectangle. Okay, all segments are considered as rectangle. Okay, and then we have to multiply it by average velocity. You need to understand one thing. See, the average velocity will be taken as v.6 here. Okay, what I'm assuming here? I'm assuming average velocity is given by v.6. I'm just assuming that average velocity is given by v.6 because, sir, because my stream is less than 3 meter deep. You can see, sir, nowhere I am getting a depth more than 3. Sir, nowhere I am getting a depth more than 3. Okay, sir. Nowhere I am getting a depth more than 3. That's why I can use this formula very simply. Okay, I can use average formula for velocity as v.6. Okay, sir, v.6 is given to me. So if I want to find the discharge in my first segment, what I will do? I will multiply this depth, average velocity and average width. Okay, sir, I will simply multiply 3.375, this is your width, by the depth is 0.6 and your average velocity is 1.4. This will give me how much discharge? Tell me how much discharge we are getting here. We will make a column for discharge. Last column will be for your discharge only. So how much we are getting here? Can you tell me how much we are getting here? Tell me finally what discharge we are getting here. Yes, multiply this. So this will be your discharge in first segment. Let me use my calculators. Wait a second. Yes. So here is my calculator. Find it quickly. Yes, so discharge in the first segment will be 3.375 into 0.6 into 1.4. I will get it as 2.835. 2.835. Obviously, it will be in meter cube per second. So this is your first segment discharge. Okay. Second segment. sir, 3 meter width into depth is 1.5. Consider your segment as rectangular. Into 3, oh sorry, into speed is 2.5. Speed is 2.5. Similarly, you will multiply 3 into 1.9 into 3 like this. Okay. Similarly, you will multiply 3 multiply 3 by 1.6, multiply it by again 1.6, multiply this by depth 0.9 and velocity 1. Yes, so second value which we are getting here is 3 into 1.5 into 2.5. This is 11.25. Multiply this 3 into 1.9. Wait a second. 3 into 1.9 into 3. We are getting it as 17.1. Again multiply 3 into 1.6 into 1.6. We are getting it as 7.68. And again multiply 3.375 multiply by 0.9, we are getting it as 3.0375. 3.0375 meter cube per second. See, these are all the discharges. See, these are all the discharges. These are all the discharges. This is your discharge in the first segment, second segment, third segment, fourth segment, and fifth segment. So in all the 5 segments, sir, in all the 5 segments, I have found out the discharges. Now, the final discharge, the total discharge will be equal to what? The total discharge in all these segments, when I will sum it up, it will be equal to what? Sir, when I will sum it up, it will be 3.0375 plus 7.68 plus 17.1 plus 11.25 plus 2.835. We are getting it as 41 point. Simply sum up all these segmental discharges, you will get it as 41.9025 meter cube per second. Are you getting the same discharge? Are you getting the same discharge? Yes or no? Yes. So when you will sum it up, okay, when you will sum it up, sigma q will be equal to this much only. Okay, so I hope this thing is clear to you. So this is how we use area velocity and divide my entire river segment into small segments, and we consider each segment as rectangular segment. We will find average width of each segment, and depth is already measured. Okay, depth is already measured, and we will also measure velocity by moving my boats at different intervals. See, this interval can be different. See, we have taken in this example 3 meter interval gap, but it can be different also. So for that you have formula. Okay, so for that you have formula. So for that you can use these formulas. Okay, W1, W2, all these are given to you. W1, W2 is given to you. Okay, so if you want to find W1, W2, so this is what? This is your W1. This is W1. W1 is equal to 3. This is what? So this is my W2. Second interval which you have moved is 3 meter again. Again you have moved 3 meter. So W3 is 3 meter. W4 is, again you have moved 3 meters. W5 is 3, and at last you are moving W6, that is also 3. That is also 3. So 6 times we have moved. 6 times we have moved, and if you will move 6 times, listen very carefully. Sir, if I have moved 6 times, I have moved from W1 to W6. I have moved first time, second time, third time, fourth time, fifth time, 6 times. If I will move 6 times, segments will be 5. Segments will be 5. Segments are 1 less in number. Okay. So this is how you use area velocity method to find your discharge. I hope it is very clear. So this is the ultimate thing. Okay, some rules are there. So shall I proceed? Tell me, shall I proceed? Is this thing clear to you? So 3 steps you have to perform. Only 3 steps you have to perform. The very first step is find. See, in 3 steps you will find the answer. First step is find average width. Okay, find effective width. First step is find effective width for all segments. Find effective width for all segments. Second step is, sir, in second step what I will do? I will find average velocity if I am using 2 point or something. Okay, second step is find average velocity for each segment, and at last multiply them. In the third step, what I have to do, I have to multiply all these. In the third step, you have to simply apply this formula. Okay, find summation q simply by using find summation q. Wait a second. Find total discharge. Find total discharge simply by using summation formula. Average width, depth into your average velocity, where I will be moving from 1 to n. If n segments are there, then I will move n plus 1. If n is the number at which I am moving, then n minus 1 will be the number of segments. Okay, one difference is there, one gap is there. So these are the three rules with the help of which you will find area velocity. With the help of which you will find discharge using area velocity method. Okay, so I hope this is clear. So I hope this is clear now. Okay, perfect. Perfect. Now we'll proceed. Now we'll proceed further. Okay, wait a second. We'll proceed further. Now you need to understand one more thing. One more thing you have to understand. See, this method is used generally when this method is, see, some rules are there. Okay, some let me write one thing. The area velocity method gives the area velocity method gives good result. The area velocity method gives good results if the area velocity method gives good results if 3 points are there, 3 recommendations are there. Okay, the very first recommendation is, see, there are 3 recommendations. I will write all these 3 recommendations are there. If you want to achieve good results after using area velocity method, 3 rules are there. Sir, tell me those 3 thumb rules. The very first rule is that width of each segment, okay, width of each segment should not be greater than 1 by 15th, should not be greater than 1 by 15 to 1 by 20th of width of entire river, of width of stream or entire river. Okay, sir, it means that when I am dividing it into different sections, I have to consider this thing. See, if entire section is let us say 100 meters, so I will take 1 by 15th or 1/20th or 1/15th of this width, and each width will not be more than this value. Okay, so let us say if my river is 100 meters wide, then I will divide it by 20, that is 5. So all the segments which I am taking here should not have width more than 5. Okay, so this is the first rule, that width of, why, see, we have to see why we are not taking more width, because see, if lazy people will be there, if lazy people are there, they will, you know what they will do, they will go across this river, they will stop only at the middle, they will stop here, and they will only give you 2 segments only. Okay, what they will do, let us say river is very huge, okay, river is very wide, they will stop here, and done. You will only have 2 segments. Okay, sir, this is my first segment and this is my second segment, only 2 segments are there, so this should not be there. In order to get proper value, sir, what I will do, I will do more number of divisions. See, if you will do more number of divisions, okay, if you will get lesser width, then obviously the answer which you will get will be more accurate. If you will divide your river into more number of segments, the answer will be more accurate. Yes or no? The answer will be more accurate. So this is the thing. You have to divide it into proper number of segments. Okay, you should not be lazy there. You should not be lazy there that you are dividing into very small number of segments, so that more inaccuracy is there. Understood, sir? So in order to ensure, you can say, accuracy, I will do proper I will divide it into proper number of segments. Okay, now the second thumb rule is, sir, discharge in each segment should be less than 10% of the total discharge. Okay, 10% of the total discharge if you want to get good results. So total discharge, see, your total discharge is 41.9025. Find 10% of this. So 10% is 4.1 around lump sum. It is 4.1 meter cube per second. Okay, lump sum it is 4.1 meter cube. So each segment, not even a single segment, should have discharge more than this value. Okay, sir. So this is less than 4.1. Okay, this is not less than 4.1. This is also not less than 4.1. This is also not less than 4.1. This is less than 4.1. So you can see second thumb rule is failing here. Second thumb rule is failing here. Why, sir? Because you can see that discharge in these segments is exceeding 10% of the total discharge. And this rule is again implying the same meaning. Okay, we will not divide segments. Okay, we will not divide segments into such bigger portions that they will accommodate more and more discharge. Okay, it should be divided into so many small segments so that discharge is properly divided. Okay, so we have more number of segments, and if more number of segments will be there, we will have more accuracy. At last, we have last thumb rule, that difference of velocities in adjacent, difference in velocities in adjacent segments, difference in velocities in adjacent segments, difference in velocities in adjacent segments should not be greater than 20%. Should not be greater than 20%. So this is it. So two average velocities between these two segments should not be differing by more than 20%. Okay, so this is it. So these are some rules which you can use, with the help of which you will get good results. Okay, these are not so important, but yes, it can be asked in your engineering services prelim examination. That's why I have told you. Okay, now we'll move on to the next method, which is my dilution technique method. Wait a second, let me drink some water. Yes, what I'm saying here is we have dilution technique. Wait a second. Okay. Yes, so now we'll discuss dilution technique. Okay, dilution technique with the help, see, this dilution technique is a method. See, there are two methods basically. We have one method which is known as gulp method or integration method or sudden injection. See, in this injection method, very simple method, listen very carefully. So we have y-axis, and on this y-axis we will write the concentration of the tracer, and here on the x-axis, we have time. Okay, on the x-axis we have time. So listen very carefully. So what we have here in this, let us say we have a stream. Okay, let us say this is your river. Let us say we have a turbulent river. Okay, so this is your section 1, this is your section 1, and this is your section 2. Listen very carefully. Okay, this is your section 2. Understood, sir? Now what I will do here is, you all know that in this stream certain discharge will be there. Let us say that discharge is Q. Let us say the discharge which is flowing in this river is Q. We are seeing this river from the top. Okay, sir, clear now? Now what I will do is, I will inject at this section 1, I will inject a chemical here. Okay, I will inject a chemical at section 1. Okay, so you need to understand the concentration of this chemical will be like this. The concentration of this chemical, which I will show here is, wait a second. Immediately you will see that at section 1, this is your concentration at section 1. This is your concentration. This is, see, within let us say 5 seconds or 10 seconds, I have injected a tracer, a chemical. I have injected a chemical. Okay, let us say this is indicating your this is indicating your concentration at section 1. This is indicating your concentration at section 1. See, concentration at section 1, I will denote concentration at section 1 with C1. Okay, C1 is what? Sir, C1 is concentration of tracer. C1 is concentration of tracer. Tracer is a chemical. Tracer is a chemical or some color which we can locate easily, whose concentration we can measure. Okay, at section 1. Okay, now what is C2? C2 is concentration of tracer. C2 is concentration of tracer at section 2. You need to understand, if I am injecting a chemical at section 1, then obviously after some time it will reach 2. Obviously, sir, this tracer will reach segment 2. Yes or no? Tell me this thing. Let us imagine this river is already carrying that tracer. Let us imagine this river is already carrying some chemical. The chemical which I am inserting here, let us imagine that this river is carrying that chemical already, and the concentration of that chemical in the river already will be termed as C0 or background concentration. Okay, see, what is the meaning of background concentration? Background concentration means that a small initial concentration of that chemical which you are using, a small initial concentration of that tracer or chemical in the stream. Okay, generally you will see that the chemical which you are injecting is not found in a stream. Generally you will observe this. Generally you will see that concentration is 0. So at section 2, listen very carefully. At every section initially, when you have not injected anything, listen very carefully. Sir, initially I have not injected anything. When I have not injected anything, then at that time concentration at all the sections will be same, C0. Okay, C0 will be there. Okay, so initially what you will see that at section 1, C0 was there, section 2 C0 was there. At section 2, if I will draw the concentration at section 2, I will see that initially there is C0. Initially the graph will be C0. Okay, initially the concentration is C0, but when I will inject it here, after some time, you know, this chemical will reach here. When this chemical will reach C2, you will see that concentration at section 2 will start increasing. And when this tracer will flow away, you will see that concentration will come down again, and again it will become equal to C0. Because that is the background initial concentration which will always remain there in the river. Okay, this is C0 again. So this is what? This is the graph of concentration of tracer at section 2. This is your concentration at section 2. So this graph is indicating concentration at section. See, at section 1, immediately concentration increases because you have in gulp. Gulp means immediately. Suddenly you have injected a tracer here. Okay, suddenly you have injected a tracer here. I hope this thing is clear. So what happens here? In this method, sir, point we need to understand. Sir, in this method, what happens? The tracer, a chemical. Tracer means a chemical which can be traced. Okay. So, sir, what you are saying here is the tracer is injected suddenly, or we can say, sir, it is not injected continuously. The tracer is not injected. The tracer is not injected continuously. Sir, the tracer is not injected continuously, but suddenly, immediately, all of the tracer I will drop immediately. Okay, suddenly at section 1. At section 1 with concentration C1. Okay, sir, if I am doing this, if I am doing all these things, then how I will find the discharge? We will use a simple formula. If we want to find the discharge, simply multiply, okay, volume of tracer multiplied by C1 divided by C2 minus C0 integration from T1 to T2, okay, dt. What is T1 to T2? I will make you understand this entire formula. Okay, listen very carefully. See, let us try to understand the meaning of these terms. Tell me, sir. So this is what? This is the discharge of stream which we are interested in finding. This is the discharge of stream which we are interested in finding. Okay, sir. Sir, this is the volume of tracer which will be given in the question, like how much volume we are injecting here. 5 centimeter cube, 10 centimeter cube, like that. Volume of tracer. This will be the concentration of tracer which you have injected. Okay, concentration will be C1. Now what is C2 minus C0? See, C2 in this diagram is indicated as the peak. This is your C2. This is your C2 thing. Okay, sir, this is my C2. Understood? Clear? This is C2. See, sir, initially in the river, C0 concentration was every time there. Every time you can see that C0 was there. But how much extra volume of, you can say, how much extra amount of tracer is there? So you need to find this area. If you want to find this area, you have to do what? Let us say this is time T1. Okay. Let us say this is time T1, and let us say the effect of this injection, and let us say because of this injection thing, because of this sudden injecting, you will see that effect at section 2 will remain from this time to this time. Okay, you need to understand, because of this injection, tracer will leave section 2, and at section 2 the effect will remain from time T1 to T2. So if you want to find the area of this, thing, what you will do, you will integrate. You see, this is dt, and this is what? C2. This is C0. C2 minus C0 is this thing. Okay, so I will minus C2 minus C0 dt. You will get the area under this curve, or simply you need to find this area. Okay, simply you need to find this area. See what this area is indicating, sir. This area is indicating actually what? Sir, this area is simply indicating what? Sir, it is indicating me the effect. See, when you will inject the tracer at section 1, it will reach section 2. At section 2, when it will reach, obviously this graph will go up. So how much extra volume you are getting there, that you want to write here. Okay, so the area under this graph I want to evaluate. Okay, so let us solve one question with the help of which we will be able to understand this very, very clearly. Okay, see, I hope now it is very, very clear why this method is called as gulp method, or integration method, or sudden injection, because we inject chemical suddenly. Okay, whose volume is V, and whose concentration is C1. Okay, whose concentration is C1. So I hope this thing is clear to you. Okay, sir. Now let us solve this question. With the help of this, we will be able to understand the entire concept very clearly. So in this question, sir, let me draw this so that it is more clear. Okay, sir, in this question it is saying, in the gulp method of stream gauging by dilution technique, 60 liters of chemical X. So the volume which is given to me, is 60 liters. Yes or no? Understood, sir? Volume given to me is 60 liters. Okay, sir. First thing is given to me 60 liters. No problem. Second thing is chemical X with concentration of 250 gram per liter. So secondly, concentration is given to me. Concentration of that chemical is that if we have 1 liter chemical, in that 250 gram we have mixed. Okay, the amount of chemical is 250 grams. So concentration is 250 grams per liter. Okay, is introduced suddenly into stream at section 1. Okay, at a downstream monitoring section, downstream means when you are measuring for section 2. Okay, so what you are saying here is, sir, what you want to say here is that, see, we will draw section 1 here also, we will draw section 2 here also. Okay, so you need to understand that at section 1, sir, at section 1 you are simply saying that we have injected immediately. Okay, yes, 250 gram per liter, this is the concentration. Let us say within 5 seconds, like that. Within 5 seconds or 1 second or 2 seconds, we have injected entire chemical at section 1. Obviously this concentration will reach section 2. Okay, now at a downstream monitoring section, the concentration profile of chemical X that crossed the section was found to be a triangle with a base of 10 hours and a peak of with a base of 10 hours and a peak of 0.01 ppm, which means after some time has passed, obviously this chemical will reach section 2. Yes, sir. After some time it will reach section 2. Let us imagine that at section 2 we have no chemical. Okay, initially let us imagine in the river there was no chemical. Okay, let us assume C0 as 0. Initially we are assuming that in the river we have no tracer. Okay, so initially here when we are measuring at section 2, no chemical was there. Sir, no chemical, but after some time what I will see, after some time obviously this will reach there. When it will reach there, sir, what will happen? Immediately, sir, you will see a triangle. Sir, they are saying immediately, sir, you will see a triangle. Okay, you will see a triangle whose effect will remain there for 10 hours. Okay, whose effect will remain there for 10 hours. They are saying this in the question. Sir, this is what? This is 10 hours. They are saying at section 2 was found to be a triangle with a base of 10 hours. This is the base of 10 hours and the concentration, this concentration will be 0.01 ppm. Okay, this concentration will be 0.01 ppm. Okay, so C2 will be 0.01 ppm. ppm means milligram per liter. You all know this. ppm means milligram per liter. So this is what? 0.01 milligram per liter. This is gram per liter. This is milligram per liter. Okay, so I hope this thing is clear. Now what you have to do, you have to find area. Now, sir, if I want to find discharge, see, you need to understand one thing. This is the graph for concentration at section 1. This is the graph for concentration at section 1, and this is the graph for concentration at section 2. This is the graph for concentration at section 2. Understood? Now if I want to find the volume, sorry, discharge, the formula is volume into C1 upon area of this triangle, which is C2 minus C0 dt. Okay, let us say if C0 was there, then this triangle would have been like that. Then what you would have done, you would have find this area only. But since it is 0 initially, you have to simply find this area. So this area will be half base into height. Okay, I hope this formula is clear. This is the formula which we will use here. Same. Okay, so volume is how much? Sir, simply put the values. Volume is how much? 60 liter. Listen very carefully. Sir, volume is how much? 60 liter. Understood? Concentration of tracer is 250 gram per liter. So I will write 250 gram per liter here. Okay, that is also very clear now. At last, what I will do, I will find the area of this triangle. So in order to find the area of this triangle, what I will do, half into base is 10 hours. See, convert this R thing into second, because I want to find discharge in meter cube per second. So I have to convert this R. You know that in 1 hour we have 60 minutes and in 1 minute you have 60 seconds. So you have converted into second. Okay, you have converted R into second, and this height is 0.01 milligram. 0.01 milli means 10 power minus 3. Milli means 10 power minus 3. You all know this. Milli means 10 power minus 3 gram per liter. Okay, what we have done, we have removed milli. Okay. Yes. Hello, Sudhanshu. Hello, dear. Okay, so we have removed milli here. Understood. Now find the discharge. How much we are getting, Sushil? Find the discharge. How much we are getting here? So what will happen here is, we will get the answer in liter per second. Sir, this gram per liter thing and this gram per liter thing will get cancelled. You will get the answer in liter per second. Tell me how much we are getting here. Sushil, tell me. We will get the answer in liter per second. Solve it. Tell me how much discharge you are getting. Tell me how much discharge you are getting here. Yes, find it quickly. Yes, find it. How much we are getting? Yes, perfect. We are getting it as 83 Solve it, quickly solve it. Tell me how much we are getting here. How we are getting it as 8333.33 है ना. Yes, we are getting it to be, we are getting it as 83, we are getting this as 8333.33 liters. Okay, this much, this is a huge amount of volume. If you want to convert into meter cube, you will divide this by 1000, divide this by 1000, divide this by 1000. Okay, you will get it as 83.33 meter cube per second. So this is how we find discharge. Okay, this is how we find discharge using your gulp method. So I hope this thing is clear. Kindly write yes if this is clear. Okay, so this is the formula. This is the formula with the help of which you can find your answer. Okay, so basically you don't have to integrate, you will get some triangle or something in order to compute your area. Okay, now we'll find now we'll use the second method. Now what I will use here is, now I will use the second method. Okay, so this was the first one. I hope this is very clear to you. Now I will use the second method, which is your constant rate injection method or plateau gauging. Okay, see what we do in this thing. What we do in this, basically imagine we have a river. Okay, imagine we have a river or a stream. This is your, again let us say this is your section 1 and let us say this is your section 2. Is this last method clear? Gulp method is clear to you? Now we will use your second method. Second method is constant rate injection method or plateau gauging method. Okay sir, so what happens in constant rate injection method or plateau gauging method? See, we will inject, what I will do, we will inject a tracer. We will inject a tracer. Okay, the discharge of tracer will be QT and the concentration of tracer will be C1. Concentration of tracer will be C1. In your river, the discharge is Q0. In your river, the discharge is Q0. And initially, let us say the tracer concentration is C0. Background concentration, okay. Initial concentration is C0. That is your background concentration. The discharge which will reach at section 2 obviously will be sum of both of them. So it will be Q0 plus QT. But yes, one thing is for sure, that this discharge of tracer will be almost negligible to your discharge of river. So we can neglect it also. Okay, we can neglect it also. And the concentration at section 2 which you will receive is C2. Which you will receive is C2. So this is the concept here. Now, if I am going to draw concentration versus time graph. Now sir, if I am going to draw concentration versus time graph for constant rate injection method, what I will observe here is, wait a second. So what I will observe here is, sir, that at section 1 we are continuously injecting it. That's why you will see, that's why sir I will observe that concentration at section 1 is constant. Concentration at section 1 is constant, sir. Why? Because I am continuously injecting it at constant rate. Concentration at section 1 is constant. Okay, concentration at section 1 is constant because I am continuously injecting here. Okay sir. Now when we haven't started injecting the tracer, then initially at section 2, the concentration was C0. Sir, initially the concentration was C0. No problem. Initially the concentration at section 2 was C0. But what will happen when this tracer will reach there? You will see that immediately the graph will start increasing, and after some time it will become constant. It will start increasing and after some time it will become constant, and that value will be equal to C2. So at section 2 I am seeing that initially it was C0, concentration of tracer was C0, but after some time it becomes constant, equal to C2. Yes or no? Sir, after some time it becomes constant, equal to C2. So in this method was basically, what is the difference? from the last method? Sir, basically the difference is that there in the last method we have injected the chemical immediately, suddenly, in gulp manner. Okay, quickly, immediately you can say. But here what we are doing here is that tracer is being injected constantly, okay, continuously. Sir, here tracer is being injected. Sir, here tracer is being injected continuously. Sir, here tracer is being injected continuously. This is the difference. Okay, so if I want to find the discharge, see, you can apply the continuity equation. See, this multiplied by this, you will get the volume of tracer. You will multiply this, you will get the volume of tracer. So by continuity equation, you need to understand, you can write this equation like Q2 into C0, sorry, Q2 into C1, Q2 into C1 plus this is Q2, this is Q0 into C0, this is Q0 into C0. Okay, so this is the total volume of tracer which is at section 1, and at section 2, obviously at section 2 the total amount of tracer which you have is Q0 plus Q2 into C2. Okay, this is your continuity equation. Whatever tracer is there, that will be at tracer at section 1 will be equal to tracer at section 2. So this is your continuity equation. So from here you will find Q0. Okay, from here you will find Q0. Find Q0. Q0 will come this side and this will go that side. So you will write Qt will be C2 minus C1. Okay, or bring this Qt C2 here. So I will write the formula for Q0. If you will solve this, this is very simple to solve. Okay, this will be very simple to solve. From here you want to find Q0. Q0 is discharge of river. Okay, so bring this Qt term here and bring this Q0 term here. So minus C2 will be here. So what will be the formula? Q0 will be Qt C1 minus T2 upon, and this will go there. So it will be C2 minus C0. Okay, the C2 minus C0 will be here and it will come down. So this is the ultimate formula here. This is the formula which you can use here in order to find your Q0. Okay, so Q0 again is giving me the discharge in the turbulent stream. This is what? This is your discharge of stream. Sir, this is the discharge of stream which I want to find. Okay, C1 is initial concentration. Okay, this is C1. This is C2. This is C0. Okay, so all the things are clearly mentioned here. C2 means what? C2 is different thing. C2 means concentration has become constant after some time. Okay, when you will continuously inject from section 1, at section 2 after some time you will see that it will increase, but since it is coming continuously, at section 2 you will see that discharge will become concentration will become constant. Okay, so C2 is what? C2 is constant. C2 is what? Constant concentration at section 2. Now I will give you an example with the help of which you can use this formula in order to find the discharge of stream. So let us say we have this example. Okay, so I hope this formula is clear. Now we'll use one example with the help of which this will be clear. Okay, so tell me, sir, the example. I will apply this formula. So in this question, sir, it is saying a 25 gram liter solution, a 25 per gram liter solution of a tracer was discharged into a stream at a constant rate of 10 centimeter cube per second. Okay, sir, you are saying that we have a river here. Okay, and this is your section 1, this is your section 2. Okay, sir, at section 1, okay, sir, at section 1 discharge is being inserted. How much tracer discharge is given to me? Sir, 10 centimeter cube per second. Okay, how much tracer discharge? Sir, 10 centimeter cube per second. And the concentration is 25 gram per liter. Concentration of tracer is 25 gram per liter. Q we have to find. Initially in the river, they are saying initially in the river the background concentration was found to be 0. Initially there was nothing. Initially no tracer was there, so C0 is 0. So C naught is 0. Understood. Now here the discharge will be Q plus QT. Here the discharge will be Q plus QT, and the concentration at section 2 after long time, concentration at section 2, see, they are saying at a downstream section sufficiently far away, the dye was found to reach an equilibrium concentration of 5 parts per billion. Okay, of 5 parts per billion, 5 parts per billion ppb. Okay, after some time the discharge at section 2 or downstream section will become constant, so 5 parts per billion. Understood, sir? Now if I want to find, sir, if I want to find your discharge, I have to use this formula. Okay, formula is Q naught equals QT C1 minus C2 upon C2 minus C naught. Okay, sir, so we will use this formula. Clear? Now we will write all the values. So this discharge is given as 10 centimeter cube per second, so I will write it here. Okay, so the discharge QT is 10 centimeter cube per second. So 10, see, we will convert this centimeter cube thing into meter cube. Now you need to understand one thing. See, 1 centimeter is 1 by 100 meter. You all know this. Okay, when you will cube it up, when you will cube it, it will be 100 cube. That means 10 power 6. So you have to multiply this centimeter cube. You have to, if you want to convert centimeter cube into meter cube, you have to multiply it by 10 power minus 6. You have to multiply it by 10 power minus 6, because 1 centimeter is 1 by 100 meter. When you will take cube, okay, 1 cube is 1 only, but 1 by 100 cube is 10 power minus 6. So you have converted this discharge here. Okay, now C1 is what? Sir, C1 is 25 gram per liter. C1 is 25 gram per liter. Now 25 gram per liter, you need to understand, concentration is of, see, 25 gram per liter, you need to understand, sir, water concentration is 25 gram. 1 liter weight, 1 liter of water weighs how much? Sir, 1 liter of water generally weighs 1000 gram. Okay, sir, 25 gram is your weight of tracer, and approximately 1 liter, that means 1000 gram is the weight of your solution. This is solution, this is solute, the solid which has been dissolved in the solution. So when you will write, when you will divide it, you will get concentration as 0.025, 25 upon 1000. Simply we are considering this concentration as fraction. Okay, so understood, sir? Now C2. Now what is C2? C2 is 5 parts per billion. 5 parts per billion. Billion means 10 power 9. Billion means 10 power 9. So 10 power 9 means 10 power 9 means parts per billion. Billion means 10 power 9. When you will bring it up, it will be 10 power minus 9. Okay, upon C2, 5 into 10 power minus 9 minus 0. Understood? Now see, this is 0.02 and this is equal to 0.00000000009. Sorry, 5. This is very small. You can consider this almost equal to 0. When you will subtract 5 into 10 power 9, which is very small, you can consider this as 0. So finally what I will get here is, Q naught is, Q naught will be this multiplied by this. So finally what you will have, see, this is gone. Okay, so this is 10 power minus 6. This will be 2. 2 into 25 is, see, this is 10 power minus 3. This is 10 power minus 6. So 10 power minus 3 minus 6 is minus 9. You will get it cancelled. Now 25 into 10 by 5. 25 into 10 is 250. Divided by 5, it is 50. So finally what you are getting here is, 50 meter cube per second. 50 meter cube per second. This is our final answer. Okay, so I hope this thing is clear. With the help of this, you will be able to find your discharge thing clearly. Okay, is this thing done? So this is the way with the help of which you will be able to find your discharge. Okay, so 25 by 1000 is, sorry, gram. 25 by 1000 is 0.025. Now the method which we have is electromagnetic method. See, in electromagnetic method, what we are doing here is, you can see that at the stream, at the bottom of the stream, you have large coils. Okay, you can see these large coils are placed in ducting. Okay, and is buried at the bottom of channel, and these coils are conducting current, okay, are carrying some current. Obviously, due to this carrying current, you need to understand magnetic field will be developed here, okay. Sir, in this what is happening? Sir, large coils, sir, large coils are buried at the bottom of channel, are buried at bottom of channel which carries current, are buried at bottom of channel, are buried at bottom of channel, are buried at bottom of channel which carries current, okay. So it will carry current, and you all know that current creates magnetic field, due to which magnetic field is present, due to which magnetic field is present, due to which magnetic field is present. And this flow of water, listen very carefully, this flow of water which is coming, we have in this area magnetic field, and this magnetic field will be cut by this flow, yes or no? So magnetic field is present which is being crossed, magnetic field is being crossed by the flow of water, okay. It is being crossed by moving water, okay sir. Now what will happen? Now since it is being crossed by moving water, this thing causes induction of EMF, or you can say induced EMF is produced, because of which a small current will be generated because of this crossing water, okay. So a small EMF which induces a small EMF, which induces a small EMF across conductor, and because of this, sir, a small EMF across conductor, sir, current will be generated, okay. Current will be generated, which is measured by electrodes, which is measured by electrodes, okay, provided at sides of channel, okay. So basically, sir, you are simply saying, now we have flow, more the discharge, see, more the discharge, more is the induced EMF, and because of that EMF you have induced current, okay. So more is the induced current, which means the discharge is more, so you need to understand this induced current, okay, if this is more, then we have more discharge, okay. And we have some empirical formula also. This discharge is given by K E D upon I, okay, plus K2, okay. See, what is the meaning? D is depth of flow, D is depth of flow, okay. D is depth of flow. I is the current in the coil, initial current, okay. I is the initial current in coil. Now let us say whatever current is there in the coil initially, and let us say whatever depth of flow is there, you will find you will write the value of constants K1 and Q2 after calibration. You will put the value of E, okay. More the induced EMF, more the discharge, okay. This we have already discussed. So with the help of this, see, this is very costly method, obviously this is very costly, you all can understand. So obviously we will not use this one. So this is your electromagnetic method. Then we have ultrasonic method, okay. What we do in ultrasonic method, okay, in ultrasonic method what we do, let us say we have a river section, okay. This is a river section. From this point A we are sending a sound signal. Sonic means sound, okay. You need to understand, sonic means sound, okay. Understood, sir? Now we will send a signal, sound signal from A to B. Sir, we will send a sound signal from A to B, and then we will send it back from B to A, okay. Sir, in my river section I have put a transmitter and a receiver. So section, wait a second, sir, this will give you signal. Let us say this length is L. Let us say this distance is L. Okay. Let us say the velocity of sound is U. U is the velocity of sound. Let us say U is the velocity of sound in water. And let us imagine the velocity of river is V. And let us say this angle is theta. Okay, now when you are coming from A to B, how much time will my sound take? Time is distance upon speed. Distance is L. Speed will be C. This sound is coming with the speed U. It is coming with the speed U. And because of this flow, this is V cos theta. When you will resolve it, it will be V cos theta. So that will be added. Okay, water will help your sound to move quickly from A to B. So what I will get? I will get V cos theta. So distance upon speed. Speed is U plus V cos theta when it will travel from A to B. When it will travel from B to A, obviously then the speed will be speed of sound minus. See, if this is V cos theta, this is V cos theta, this is minus V cos theta. When it has to travel back again, then flow will try to reduce the speed of your sound. Okay, speed of the sound will be decreased. So more time, it will take more time to reach there. Okay, now 1 upon T1 is what? Switch it. 1 upon T1 will be U plus V cos theta upon L. It will be U plus V cos theta upon L. 1 upon T2 will be U minus V cos theta upon L. Okay, switch it, subtract. Now U minus U will be gone. V minus minus will be plus 2V. Okay, so I will write here the velocity formula from here will be L upon 2 cos theta. See, L upon 2 cos theta. This L has gone up, 2 thing has come down, 2 cos theta thing has come down, and this is your 1 upon T1 minus 1 upon T2. Okay, so for U has get cancelled, 2V cos theta is there. So L has gone up, 1 minus T1 T2, L has gone up, and 2 cos theta has come down. So you have found out the formula for V. Now with the help of this formula, you will find average velocity. This is not the average velocity. With this velocity at particular depth, we will find. Okay, see, we have installed this. We have basically installed this. You can, let us say this is a river section. We have installed it at a certain depth. Okay, sir, we have installed your transmitter and receiver at certain depth. Okay, so this velocity will be measured at a certain depth. Now, this is your velocity at a certain depth. So with this velocity at particular depth, this is at a see, this is the top of the river, this is the bottom of the river. These are placed at some depth. These transmitter and receiver are placed at certain depth. So obviously you will measure velocity at this level. So with this velocity at particular depth, we will find average velocity. We will find average velocity. Okay, and with this average velocity, if I want to find discharge will be what? Area into V average. Okay, you can find the area of this rectangular cross section using B into D. Let us say this is your width B, and let us say this is your depth D. So B into D will give you average, and with the help of this you will find your discharge. Okay, so I hope this thing is clear. So okay, so this is your ultrasonic method. I hope this is very, very clear to you. Now we will discuss the remaining measurement of discharge methods in the next class. Okay, only one is remaining. Flow measuring structures is not so important. Wait a second. Yes, I was telling you this one. Okay, so we have finished all these 4. We will discuss the remaining flow measuring structures and your slope area method in the next class. So till here, we'll end our class today at this point only, and tomorrow we'll start with hydrograph. Okay, so hydrograph is very, very important. From there we'll continue. We'll also discuss the remaining slope area method. Okay, so I hope you have enjoyed the class and you have learned too many things here. Okay, so let me delete all these things. So Streamflow has come to an end. Streamflow has already almost ended, and in the next class we'll completely end it, and we'll start with hydrograph. See, hydrograph is very, very important. Hydrograph is very, very important. So we'll discuss that in the next class. Okay. Okay. So we'll catch up tomorrow. Basically, we'll discuss the remaining topics of your Streamflow, and we'll start with hydrograph. Hydrograph is most important because most of the questions which will be there in your GATE examination has been asked from your hydrograph topic only. Okay. In hydrology, infiltration topic is important and hydrograph topic is important. Okay. Okay, so we'll end our class. We'll catch up tomorrow. So good night, everyone. Stay blessed. Take care. We'll catch up tomorrow with hydrograph. So good night, everyone.